Welcome again students in the chemistry class. Now we are learning in the 11th class the chapter number 10, that is state of matter, and in this chapter we have to learn the two states in details, that is the gaseous states and the liquid state. Now gaseous state we already learned about the gaseous state and so many laws we are learn again into that. But now let us learn the liquid state. Now this liquid state is the intermediate state. Liquid state is the intermediate state between the liquid state is the intermediate state between the solid state and gaseous state. We know that. And the molecules of the liquids held together by intermolecular forces of attraction. That means they are intermolecular forces of attraction between the liquid molecules are in intermediate between the molecules of solids and the molecules of gases. We know that the molecules of solids are very tightly held together in a definite pattern, and therefore the solids have a definite shape and definite volume. They have different shapes such as cuboidal, cubic shape, that is rhombic shape and monoclinic shape. But such shapes are not directly formed by the liquid or the gases, because gaseous molecules are independent. There are very negligible attractive intermolecular forces between them. But the intermolecular forces of the liquid molecules are moderately strong than the solid and the gaseous state. Now, therefore, they can move within the boundary of the liquid. The molecules of liquids, due to the intermediate molecular forces, intermediately strong molecular forces, they can move about within the boundary of the liquid. And as a result, liquid possesses the properties such as fluidity. Liquid can form the fluid. All the liquids are fluidy. They have the property of fluidity. Again, they have a definite shape in which that liquid is placed in which shape of the container. They take the shape of that container in which they are placed, and therefore as a result of the moderately strong intermolecular forces, liquid possess the properties such as fluidity, definite volume, and ability to take place the container, ability to take shape of the container in which it is placed. Now, these are the common properties of all the liquids, that fluidity, definite shape, or they can take the shape of the container in which they are placed, definite volume. But different liquids are characterized by the quantitative properties. Now that there are different liquids such as water, petrol, honey, gum, etc. So many liquid are there in the nature. Now these liquids are characterized by how we can differentiate them. They are characterized by the quantitative properties. Quantitative means we can measure that property. And which are that properties? Such as density. Different liquids have different densities. Boiling points. Different liquid have different boiling points. Freezing points. Boiling points are the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. So water have the boiling point 100 degrees centigrade, at which the vapor pressure of water and atmospheric pressure are equal. So 100 is the boiling point of the water. We know that. Again, the density of water is 1. Now freezing point. Freezing point is the another property which is also different for the different liquids. Now the freezing point is the temperature at which the liquid state and solid state of that liquid are present at the equilibrium. They present or coexist at that temperature, such as ice at 0 degrees centigrade form from the liquid water. But at 0 degrees centigrade, ice and the liquid water are in a continuous coexistence state, and that is the freezing point of the water. 0 degrees centigrade is the temperature at which both of these states, solid state and liquid state, are in equilibrium, is called the freezing point. Again, the vapor pressure, next property, vapor pressure. Vapor pressure is the pressure exerted by the vapors of that liquid on the surface of that liquid. Now, vapor pressure is the pressure exerted by the vapors of the liquid on the surface of that liquid is called as the vapor pressure, but at equilibrium. Now, what is equilibrium? When the rate of evaporation and rate of condensation becomes equal of that liquid, that is the equilibrium state. So, at equilibrium, when the pressure is exerted by the vapors of the liquid on the surface of that liquid is called as the vapor pressure of that liquid. Again, the surface tension. Now, this is the tangential force. Now, surface tension is also different for different liquids. And viscosity, that is the rate of flow of the liquid. Rate of flow of the liquid fluidity is the viscosity. Now, let us learn this property one by one. Now, first we have to learn the vapor pressure. This is the first property, vapor pressure of the liquid. Now, I give here definition. The pressure exerted by the vapors of the liquid, the pressure exerted by the vapors of the liquid in equilibrium on surface of that liquid is known as saturated vapor pressure, or simply it is also known as the vapor pressure. Now, here one, that is the word, that is the equilibrium is there. Now, what is this equilibrium? Now, we know that the molecules of the liquid have a tendency to escape from the surface of that liquid, and they form the vapors about it, and this is called as the evaporation. So, molecules of liquid have a tendency to escape from the surface of that liquid and form vapor about it is called as the evaporation. We know the evaporation. Now, this is the evaporation. But when a liquid is placed in a closed container, if the container have a lid on that or it have the bell jar on that, then what happen? These vapors due to the atmospheric temperature, these vapors due to the cooling of that wall of that the lid or bell jar, they get cool and they form the liquid again. They comes into the liquid again. They return into the liquid again. Now, that is known as the condensation. So, condensation is the cooling of the vapors of that liquid. But that is initially the rate of evaporation. When we place the liquid in a closed container, the rate of evaporation is high initially. And then, as the time passes, the rate of condensation increases. But one time at equilibrium, what happens? How many molecules goes into the vapor? Exactly same number of molecules condense again into that liquid. And at that time, there is equilibrium. The rate of evaporation and rate of condensation becomes equal. And that is then the pressure at that time is the vapor pressure. Now, see here, molecules of liquid have a tendency to escape from its surface to form the vapor about it. This is known as evaporation. when a liquid is placed in a closed container, it undergo evaporation and the vapors on cooling undergo condensation. At equilibrium, when rate of evaporation and rate of condensation becomes equal, then at equilibrium, the rate of evaporation and rate of condensations are equal, and the vapor pressure is the pressure exerted by the vapors of that liquid on the surface of the liquid at equilibrium is called as the vapor pressure. The vapor pressure of water is generally known as the aqueous tension. We know that. Now let us learn the different again. What are the that is effects on the vapor pressure? Which affects the vapor pressure, and how there is the figure about this vapor pressure. There are short notes on all these properties into the examination. Then you have to give there, if there is figure present, you give the well labeled figure, again the definition of these properties such as vapor pressure, aqueous tension, that is the surface tension, such property where you have to give their definition, and which are the again the factors which affects these properties, that are also you have to given in that short notes. Let us learn the again the factors affecting the vapor pressure. Now see students, watch on the blackboard. Now this is the figure of vapor pressure of the liquid. Now here this is the that is closed container. In that closed container, the liquid is placed in the beaker. This is the beaker containing liquid, and this is the closed container, and to that closed container there we can attach the mercury manometer to measure the vapor pressure. Now when we place the liquid in a closed container, at first the rate of evaporation is higher. So many molecules from that surface goes into the upper space of that container in the form of the vapor molecules. Now as time passes, the vapor molecules get cooled and they again comes into that container again, or they get, that is the condense. And when the rate of evaporation and rate of condensation becomes equal, at that equilibrium position we can measure the vapor pressure. These are the mercury levels, and from which the vapor pressure of the liquid by using this mercury manometer is measured in torr. Torr is the most common unit to measure the vapor pressure of the liquid. Now 1 torr is equal to 1 mm of Hg, millimeter of mercury. Now let us learn the factors affecting the vapor pressure. Now nature of the liquid. How the nature of the liquid is there? If the liquid having very relatively less intermolecular forces of attraction, then they can easily evaporate because their molecules have very less intermolecular forces of attraction, so they go easily into the vapor state. So the liquid which having the relatively weak intermolecular forces possesses high vapor pressure, and these liquids which have very high vapor pressure, they easily undergo evaporation in a very few minutes. They are called as the volatile liquids. Now you know the most of the organic solvents are volatile. They can evaporate at room temperature also, and they have the very high, that is the vapor pressure. Their intermolecular forces of attraction are very weak. Now for example, petrol evaporates quickly than the motor oil. Now petrol is more volatile than the motor oil because petrol have the high rate of evaporation, that means they have the high vapor pressure. Now second property is the temperature. Now this temperature, we know that when the liquid is gradually heated, its temperature increases, and as temperature increases, as temperature rises, its vapor pressure also goes on increasing. So the vapor pressure of the liquids are higher at higher temperature. Now, what is the unit of to measure the vapor pressure? Vapor pressure is measured by means of the manometer. Manometer is the same as the barometer, but that is to measure the pressure. Atmospheric pressure is measured by the barometer. Now that is the pressure which is the that is open pressure. But to measure the closed pressure or in the container, the pressure is measured by the mercury manometer. Now the most common unit of vapor pressure is torr. Now what is torr? Torr, 1 torr is equal to 1 mm of Hg. Now we know that the 760 mm of Hg is equal to 1 atmosphere, and in this way 1 mm of Hg is equal to 1 torr. Now for example, water have the vapor pressure nearly about 20 torr at room temperature. Now this is about the first property, which is the quantitative property of the liquid, and which is the characteristic property of the liquid, that is the vapor pressure. Now, if you learn this very well and if you understand this property and about the liquids, then you can share, like and subscribe this video and tell the other students of 11 Science to subscribe it. Thank you, student.